So this video, I'm going to show you how we factor special cases. We have two special cases, and it's not necessarily that it's that much different than what we have been doing, but they are special and unique, and they serve a pretty big purpose from here on out in your math and even within this chapter, so or unit. So first one I'm going to say is perfect square trinomials. So I'm going to start with that one. And this one, again, isn't really that much different from what you have already been doing, but it is something that's going to have a purpose coming up. And let's just get this a little better focused, maybe. Hold on, sorry. It just didn't look very focused to me. So there we go. Okay. All right, that looks better. All right, I think it might be a little more focused in the center. All right, so here's the deal with perfect square trinomials. So, for example, so let's say we have x squared plus 6x plus 9. All right, so we are looking for numbers that multiply to be 9 that add up to 6. So if you are doing the little x, or the big X, sorry, I just made it smaller. We're looking for numbers that multiply to be 9, that add up to 6, and that would be 3 and 3. So the reason why this is unique is because when we get our magic numbers, they are the same. So what ends up happening is that this would be x plus 3 times x plus 3, which we could write as x plus 3 squared. Now, the reason why this works out is because our leading coefficient right here and this right here are perfect squares. So, in addition, the number that is squared is half of the middle. So that's just something that just happens. It happens naturally. It's not like we did anything specific to get that to happen. But when we have a perfect square trinomial, we end up having the same two numbers as our special numbers. So we end up with the same binomial twice, which we can write as squared. All right, so for the next one, so let's say, for example, 2. All right, so 4x squared plus 12x plus 9. All right, so if we think of our big X, we want numbers that multiply to be 36 that add up to 12. So that would be 6 and 6. Divide by 4, so we get 3 halves and 3 halves. So our answer is going to be 2x plus 3 for this one, and 2x plus 3 for that one, which is the same thing, which we could write as 2x plus 3 squared. So what happened here is that we have perfect squares right here, okay? So this is a perfect square, and this is a perfect square, so we've got perfect squares going on. The perfect square, this is going to be 2x, and this perfect square, if we take the square root, would be 3, and those two times 2 would be the middle. So same thing here. So the perfect square of this was a 1x, and the perfect square of here was a 3, and that multiplied times 2 is the middle. So again, it's just something that happens. You might not necessarily recognize it originally from the beginning, but when you go to do your big X on the side, your factors are the same number. So that's how you know it can be written as a perfect square. All right, so that's the first kind. All right, the next special case, so let me move down here, is what we call difference of squares. Difference of squares. Okay, so this is like almost the same but exact opposite at the same time. So let's see if we can get some focus going here too. Let's go. And maybe it's just me. Okay, it just didn't look very clear. All right. This one is different. This is not a trinomial. This is going to be a binomial. Okay. And what we need to think about is it's called difference of squares. So it's going to be a binomial with subtraction of perfect squares. Whoops, perfect squares. All right, so it's going to be these three things. So it's a binomial, it's subtraction because it's the difference, and the difference in math is subtracting. So it's the difference between two perfect squares. All right, so here we go. Let me give you an example. So for example 3, so let's say we had x squared minus 25. All right, now this is a binomial, and it could be a trinomial if we wrote it as x squared plus 0x minus 25. So what's happening is this binomial is a trinomial where the middle is 0. So when we think about this, we could go over here and make the big X. We want a negative 25 when we multiply, but a 0 when we add them together. And the way that's going to happen is with a positive and negative 5. So the reason why this is very similar to what we were just doing is that our factors are the same, but this time they cancel each other out to 0. The only way they could cancel each other out to 0 would be if one of them's positive and one of them's negative. But if one of them's positive and one of them's negative, they cancel out to 0, but they make a negative for our perfect square. So up here, we always have a positive 9, and then it breaks into those two. Or a positive 36, and it breaks into those two. But down here, we're going to have a negative on our perfect square, which is why it's subtracting, which is why it's called the difference, which is why it's only a binomial because they cancel each other out to 0, which causes that to essentially just disappear. So the answer to this is going to be x plus 5 and x minus 5, but we cannot write that as a squared like we could up here because they're not actually the same. The signs are different. So if we multiply this back together, the 5x and the negative 5x cancel out, so that is 0x, which means it's just x squared minus 25. So one more of those, and then I just want to show you something so that you are not fooled. All right, so let me push this a little bit more. So let's say we have 16x squared minus 81. All right, so if I look at this, I actually don't want to do this x on this one, but here's what I'm going to do instead. Now that I look at it, I don't want to multiply those two together, but I know that this would be 16x squared plus 0x minus 81. So I know that my factors have to cancel out to be 0. So I know they're going to be the same. So what I know can happen with 16x squared is 4x and 4x. And then I can get 81 with 9 and 9, But to get a negative 81, I would have a positive 9 and a negative 9. And since these are identical right here, the middle is going to cancel out to be 0. So anytime you see the difference of two perfect squares, we know that that happens because the 0 was in the middle term, and that happened because they canceled out, and they canceled out because they were the same thing, but one positive, one negative. All right, now, what I want to show you really fast is how not to be tricked. Okay, so if we look at this one, let's say we had x squared plus 36. All right, so same thing. We know that we're looking for numbers that multiply to be 36 but add up to 0. So this would be x squared plus 0x plus 36. So if we looked at this, we want 36 but add up to 0. Okay, this doesn't work. This one is prime. And the reason is because if you think 6 and 6 will add up to 36, or sorry, multiply to be 36, you're correct. The problem is it doesn't add up to 0. It won't add up to 0 unless one of them's negative. But if one of them's negative, we're not going to get a positive 36. So this one just doesn't work. The reason I knew from the beginning that it was a trick question was because this is not a difference of squares. This would be the sum of squares. And the sum of squares won't cancel out to be 0. Okay, that covers it. Again, as always, if you need to go back and rewatch anything or need a further explanation, I can certainly help you out in class.